Hi everyone, my name is Bailey Brown, and we are currently in Math for Teachers 2. Let me screen share here. And we're going to start off with Lesson 1, Module 8. Alright, Lesson 1, Module 8. So in question 1, Part A, it says to show a graph that correlates with the function of the amount of gas in a tank when a driver refills the tank in a cross-country trip. So over here to the right, we've got a graph, and it shows it going downward, upward, and then downward again. So if we go back to this first part when it goes downward, that's him driving to the gas station. He is losing gas as he's driving to the gas station. And it stays in the same spot and it goes up. It doesn't go any further to the right, it only goes up. And that's because it's being filled with gas and not traveling any distance while doing so. And then it goes down because this is him driving, somewhere in that cross-country trip. So in question 1, Part B, we've got a question that says, show a graph that correlates with the function of the height of an elevator stopping at each floor on the way up. So over here, we've got a graph, and it's labeled on the left side the height of the floors, and at the bottom it says the amount of time. So we notice that it goes up. So we've gone up a floor, and then it just stays in a straight line and goes to the right, because it has stopped on this floor, but the time is still passing. So it goes up another floor, and the time is still passing as it's waiting to go to the next floor. So it goes up, time is passing as it stopped, and then it goes up another floor, time's still passing, and so on and so on. And then Part C of this question, it says, show the graph of a correlation of a function of the height of a bouncy ball being dropped from a table. So if you notice here, we drop it, it goes down first, and back up, and down again. But each time, the wavelength becomes shorter because the momentum decreases. The ball is slowing down, and it will eventually stop and be a straight line, or completely stop. On Part D of this question, it says, show the correlation of a graph with the function of a flagpole shadow length on a sunny day. So right here at the beginning, it's a fairly large shadow, but it's going to decrease because when it hits the middle of the day, the shadow is going to be the least amount. And then as it gets closer to the end of the day, with the sun starting to set, the shadow becomes longer again until it disappears because the sun is gone. This is due to the position of the sun in the sky rotating around the flagpole. So now we're on to question 2, and it says to explain how to work the problems g of f of x when x equals 0, 1, 2, and 3. So first we're going to focus on part A, which is x equaling 0. So the g means nothing, basically, and the f pretty much means nothing. You can just ignore those, just replace the x with the number. So if you think about it, we've just got 0 plus 8, and 0 plus 8 is going to equal 8. So our x would be 0, and our y would be 8. In part B, we're going to replace this x with 1. So f of 1 plus 8. So 1 plus 8 is 9. Part C, the x is going to equal 2. So where we've got f of x, it would be f of 2 now plus 8. So we've got 2 plus 8 to equal 10. In part D, we've got x equaling 3. So the f of x is now f of 3. So 3 plus 8 equals 11. Alright, now we're on to question 3, part A. It says, graph and describe the slope of these points. So point P is at 3, 1. So we're going to go over 3 and up 1 to plot our first point. And for our point Q, we're going to go over 5 and up 5. And we're going to connect these dots with a line. Okay? And now we're going to find our slope. So to get our slope, we're going to do y2 minus y1 on top and x2 minus x2 on the bottom. So our y2 is going to be the second number in the second set of parentheses. So this is going to be 5. And it's going to be subtracting our y1, which is the second number in the first set of parentheses. And that's 5, 1. And that's 1. And then under that, it's going to be x2 minus x1. So our x2 is the first number in the second set of parentheses, and x1 is the first number in the first set of parentheses. So we've got 5 minus 3. So on top, the 5 minus 1 is going to be equal to 4, and the 5 minus 3 is going to be equal to 2. So 4 over 2 is our slope, which is also the rise over run. So if we look at the points we've already plotted, going from P to Q, we should rise 4, which is correct, and we should run or go to the right 2. So this is how we know we've done the question right, because our slope matches our points. Alrighty, on question 3, part B, it says graph and describe the slope of these points. So we've got R at 5, 8, so we're going to go over 5 and up 8 to give us that point. And for our point labeled S, it's going to be over 5, down 8. So we'll place that point and we'll connect the two with a line. To get our slope, we're again going to do the y2 minus y1 over x2 minus x1. So our y2 is going to be the negative 8, and then we're going to subtract our y1, which is 8. And our x2 is going to be 5 minus our x1, which is 5 also. So this is going to give us our rise over run, or the slope. So our rise is negative 16, which means we're going to fall because it's negative. So we should go down 16 points. And our run is 0, so we're not going to go anywhere. So we've done this correctly because it is a straight line. Question 3, part C. Graph and describe the slope of the points. So we've got point U, which is at negative 1, negative 4, and point V, which is at negative 4, negative 13. So we're going to start with our point U and go to negative 1. So we're going to go over 1 to the left and down 4 because it's a negative, and plot that point. And our V, we're going to go to the left 4 because it's a negative, and we're going to go down 13 because it's also a negative. And to get our slope, we'll do the y2 minus y1, so negative 13 minus 4. So when we're subtracting a negative, it's basically the same thing as adding. So if you wanted to change that into being 13 plus 4, you would still come up with the same number, which is a negative 9 on top. And for our bottom part, we've got x2 minus x1, and our x2 is going to be negative 4 minus the x1, which is negative 1. So again, you could do negative 4 plus 1 or negative 4 minus negative 1, and you'll come up with the same answer either way. So this gives us our slope, which is negative 9 over negative 3. So if we look at the dots, then if we go down 9 because it's a negative, and we go to the left 3 because it's a negative, we should have the same answer, and we do. Question 4, part C, or part A, excuse me. It says show and explain the graph of the following functions, as well as show the similarities and the differences between the graphs. So we're going to start with y equals x2, x squared. So I just picked some random points for our x. I chose negative 3, negative 2, 0, 2, and 3. So if we're doing negative 3, that would be our x, and then the y, we're going to have to square what our x is to give us our y. So negative 3 squared is a positive 9. So we will go ahead and plot that point, which is going to be over 3 to the left and up 9. And our negative 2 squared is 4. So our points are going to be negative 2, 4. And we're going to go to 0, and 0 squared is 0. So our point's going to be right there in the center. 2 squared is 4, and 3 squared is 9. So now we'll just need to connect all of these points with a line. And if you notice, this bottom dot, is right there in the center of the graph, and the other dots, they line up with each other. Moving on to part B, we've got y equals x squared plus 7. So it's going to be very similar to the last one, except for you're going to be moving up 7. The math is going to be a little different also. So we've still got the same points, -3, -2, 0, 2, and 3. So -3 squared is 9, and then we're going to add 7 to this. So our y point is going to be 16. So our point there, our x is going to be -3, and our y is 16. So we're going to go over to the left 3 and up 16. And there's our point. -2 squared is 4, and 4 plus 7 is 11. So our point is going to be -2, 11. 0 squared is still 0, but we're adding 7, so it will just be 0, 7. 2 is going to be 2 squared, which is 4. 4 plus 7, again, is 11. And 3 squared is 9, and 9 plus 7 is 16. So we're going to connect these dots with a line, and pay attention to where this bottom dot is, because it starts at 7, and the dots, again, are also lined up with each other. This next one is very similar, just the position is going to be slightly different. I don't know what was going on with that. Let's see if it'll let me now. Sorry about this. I'm not sure why it's not wanting to load. We'll just have to go based off of my slides. Okay. So in this one, we're going to do this very similarly. So we're going to do the same points again, but instead of us adding 7 each time, we're going to subtract 7. So our x point is going to be -3, and our y point is going to be 2, because -3 squared was 9, and 9 minus 7 is 2. So our first point is going to be over 3 to the left and up 9. Okay, or up 2, excuse me. Our x point is going to be -2, and -2 squared is 4. 4 minus 7 is going to be -3. So we're going to go over 2 to the left because it's a negative, and down 3 because it's a negative. Our 0 point, 0 squared is 0, and 0 minus 7 is going to be -7. So we're going to go nowhere. We're going to stay right here on 0, and we're going to go down 7. 2 squared is 4, and 4 minus 7 is -3. So we're going to go over to 2 and go down 3 because it's a negative. And then again with the 3, 3 squared is 9, 9 minus 7 is 2. So our point is going to be over 3 to the right and up 2. And we're going to connect all of the dots. Notice again where the very bottom point is. It's down here at -7, and the dots still line up. So the similarities and the differences. They're all very similar because of the shape that they make, but the difference is where that bottom dot is. So this y equals x squared, the very bottom dot starts at 0, 0. and the x squared plus 7 is at 0, 7. And x squared minus 7 is down at negative 7. So it's almost as if you had shifted it all the way up to the 7 for the x squared plus 7 and brought it down. Just move the whole thing down to negative 7. It's the same exact thing, you're just moving it up and down. So we'll move on to question 5 now. We've got y equals negative 3 over 4x plus 5, and the point R is 6, negative 1. So we would start by plotting our 6, negative 1, and you would go over the right 6 because it's a positive, and go down 1, and plot your dot and draw your lines that connect to it. Next, we're going to have to plot the y equals negative 3 over 4x plus 5. So where it says 5, there's an understood 1 underneath it, so that's going to be your first point. You're going to go over 5, up 1, and then you're going to move over to the left. You're going to move over to the left 3 because it's a negative. This number, negative 3 over 4 before the x, is going to be your slope because y equals mx plus b. So that m is going to be your slope. So we're going to move over from the 0.5, we're going to move over from the 0.51. We're going to go to the left 3 and up 4 to give us that blue point right there, this blue point right here, and we're going to connect the lines. If you notice that this orange line, it's heading upwards, it's not pointing down, it's going up. So that's going to mean that it has a positive slope. And this blue line is the complete opposite. It's going downwards. So that's going to mean it has a negative slope. Part B of question 5 is 2y plus 9x minus 5 equals 0. And point S is at 0, 3. So we'll start with our point S. It says 0, 3, so we're not going to go anywhere. We're going to stay right here, and we're only going to go up 3 and plot our point. And we will continue the lines with that. For this 2y plus 9x minus 5 equals 0, it's not in the correct form because it needs to be in y equals mx plus b form. So we will start with this first set right here. And what we're going to do first is we're going to add this 5 onto the right side. We're trying to isolate the variable y. So what we're going to do next is we're going to subtract 9x because we're trying to get this 2y by itself. So that's going to give us 2y equals negative 9x plus 5. And next, you see that y is not by itself quite yet. It's got a 2 with it. So what we need to do is divide everything on both sides by 2. Because whatever you do on the left side, you have to do on the right side. So we divided that negative 9 by 2, and we divided the 5 by 2. So y equals mx plus b. So the m is our slope, and the b is the point that we start with. So we're going to go over 5, up 2, and that's a negative. So we're going to go over 9, and then we're going to go up 2, which should give us our blue point right here. We would plot that and put our lines. These lines are perpendicular to each other because they run into each other. They're not just both horizontal. The orange line, it's headed upwards. So that indicates that it indicates that it has a positive slope. And the blue one is going downwards. It's slightly going down. It's not quite a straight line, but it's slightly going down, which means that it has a negative slope. On question 6, part A, it says show and explain the equation of the line that is a tangent to the circle of the radius 9 at point 0, negative 9, and whose center is at the origin. So we're going to create a table over here, and we've got our x point, and we've got our y point. So if we start with our x point of being negative 9, 0, we would go to the left 9, and we're not going to go up at all. So we're just going to stay right here. And then we're going to go over 9 for this 9, 0, We're going to go over 9, and we're not going to go up or down at all. So that's going to be a next point. Next, we're not going to go over left or right because the x is a 0. And the y is a 9. So that means that we're going to go up 9 and put our next dot. The next set of points is going to be 0, -9. So we're going to stay right here in the center. We're not going left or right because it's a 0. That means don't move. And the -9 means go down 9. So if we connect all of these points, we've got a circle. And we notice that it said the center was 0, that the radius was 9. So we would start right here in the center and go left, pointing towards 0, -9. And this next part, part B, is very similar. It's basically the exact opposite. We're still going to have the same points because we still got that same circle, just where we started at was a bit different. So if we were looking for a +0, +9, what we would do is we would start from the center, and we wouldn't go up or over because our x is a 0, which means don't move. And we're going to move to the right 9 spots because it's a positive. So that's going to lead us to this being the tangent of the circle. In part C, it says compare the line in part B to the line in part A. So they're two different lines and then they're on two opposite sides. But if you look here at the difference, this green line is at point -90. So that means we would move to the left 9 and we wouldn't go up or down. And the purple line, it starts with a 0, so we don't go up or down, but we only go to the right, 9. So the tangent is on very opposite sides because one's positive and one is negative. All right. Thank you all so much for watching. I hope you enjoyed and I hope you learned something new. I'll see y'all next week, and y'all have a good night.